Hello everyone. In this video, I will demonstrate how to verify that the expressions on both sides of the equation are equivalent, meaning this expression on the left is equivalent to this expression on the right. Please remember that the equivalent expressions are expressions written in different form that yield the same value for identical inputs. Now let's go over this example. In order that we can verify if both sides of the equation are equivalent expressions, we can work on one side and make sure or find out if that side is equivalent to the other side. So I go ahead and write this division for these two sides right here. Okay, so we're gonna work this left expressions out and come up with an expression to see if it's gonna come out 1 over x. So I'm just gonna go ahead and rewrite that down here. Now, we remember that if we have a negative exponent, we can make this into positive by writing its reciprocal. So this is how it's gonna look like. So we have 1. We get the reciprocal of this, so that would be 1 over x squared. So it's now a positive over, that's going to be x minus, get the reciprocal for this, that would be 1 over x. If you notice, the denominators for these two fractions are not the same. So we can go ahead and multiply 1 by x squared over x squared. And then this one is x and this one is 1. So we can multiply the first fraction with x over x. So that this expression would come out. Notice that their denominators are the same. So the denominators of these two fractions are the same and the denominator for these two fractions are the same. So we can go ahead and simplify this. Since their denominators are the same, we collect the same denominator, that is x squared, and then we subtract these two, so that is x squared minus 1. And then for this part right here, they have a common denominator of x, and then we subtract them, x minus 1. If you notice, this is an example of complex fraction. So we remember, if it's a complex fraction, we copy the numerators. I'm just going to go ahead and write that up here. Now, if you notice, this one is supposed to be x squared. So x times x is x squared. So this one is x squared. So that means this one is also x squared. So you have x squared minus 1. Okay, so what I did right here is that I copied the numerator, copied it, and then I will multiply the denominator, but this time around I'm going to flip it. So that would be x over x squared minus 1. So then we can go ahead and cross out the x squared minus 1 and x squared minus 1. So we cross this out. This means that there are two x's at the bottom. We take one x and we cross out one of the x's here. So if you notice, nothing is left on the numerator. Remember, if nothing is left, there is an invisible one left in there. On the denominator here, we are left with just x. So that is 1 over x. Now notice that this expression on the left is actually the same as the expression on the right. If you notice, the right side and the left side are the same. This means that these two expressions right here are equivalent expressions.